Welcome to the Deep Dive. This is where we take a whole stack of sources and, well, really boil them down for you. We aim to give you the clearest, most compelling understanding of a complex topic and do it fast. Today, we're pulling back the curtain on something you definitely rely on probably every single day, but likely never actually see. The world of RF feeder cables. Our guide for this is an insightful article from Cognitive Market Research. It's called RF Feeder Cables Market Trends and Future Opportunities, written by Anushka Gore, published back in February 2025 and updated just this June. So our mission, basically to unpack this really essential, often kind of overlooked component of our connected lives. We want to give you the full picture where things stand now, the challenges, and where it's all headed, so you can walk away feeling properly informed.
That's right. And it's fascinating because these cables are like the silent workhorses of all our modern connectivity. You might not even think about how much of your digital life really depends on them, from, say, your mobile data just flowing seamlessly to broadcasting your favorite shows. Get ready, because you'll discover why they're actually far more significant than you probably imagine. There might be a few aha moments.
Okay, let's get right into it then. These cables, they're everywhere, doing their job quietly.
Mhm.
But what exactly are RF feeder cables, and why should we, care enough to do a deep dive today?
Right. So at their core, RF feeder cables are absolutely essential components. Think telecommunications, broadcasting, really any kind of wireless communication sector relies on them. Their main job, their critical function, is enabling efficient and crucially reliable transmission of radio frequency signals. So getting signals between antennas and all the other network gear, think of them as high-integrity pipelines. They carry all that wireless information. And their design is specifically engineered to minimize signal loss, cut down on interference, and basically maintain the signal's integrity, even over pretty long distances.
And how do they manage that level of precision? It sounds like it's got to be more complex than just a simple wire.
Oh, much more. Yeah, it's far more than just a wire. The precision engineering is absolutely key here. We're talking about using high-purity conductors like copper or aluminum, but crucially, it's also about the advanced dielectric materials surrounding them. These aren't just for basic insulation, they're precisely engineered layers. Their job is to maintain consistent impedance and minimize energy loss. And then you've got the shielding. Often multiple layers, maybe using braids or foils, specifically designed to block outside electromagnetic interference. That ensures the signal stays clean, even in really demanding, noisy environments. But what's really remarkable, I think, is their adaptability.
Adaptability, interesting. So where do we actually see that versatility playing out?
In what kinds of applications? Exactly. Well, they come in all sorts of configurations. You've got flexible ones, low-loss types, even specially designed weather-resistant cables. And this variety makes them suitable for an incredibly wide range of uses. They're making sure your mobile calls connect seamlessly, they're powering satellite services, they underpin huge broadcast networks, and they're connecting those sprawling data centers that really form the backbone of our digital world. They genuinely ensure the integrity of the signals that, well, power our connected lives.
Okay, so knowing how fundamental these cables are, you might think it's a pretty stable market, maybe even a bit sleepy. But I get the feeling there's a surprise coming when we look at the numbers. Sounds like there's a story of maybe explosive growth. What's the current market valuation look like?
You hit it exactly right. It's anything but sleepy. According to that Cognitive Market Research report, the global RF feeder cables market was valued at approximately USD 2,814.5 million back in 2024. And it's definitely not slowing down. It's projected to nearly double, actually, reaching USD 500 and 405.5 million by 2032. That reflects a compound annual growth rate, the CAGR, of 8.5% over that period, which is pretty significant.
Wow, 8.5% CAGR.
Yeah.
For something like this, a foundational kind of unseen infrastructure piece, that's not just a number, is it? It feels like a really clear signal of a major shift. It points to this relentless, almost exponential demand for connectivity that's reshaping everything, industries and daily life. So what specific forces are really pushing this kind of rapid expansion?
Yeah, there are several powerful forces all working together here. I mean, the most obvious one is probably the ongoing global deployment of 5G networks. That alone creates a massive demand for cables that can handle those higher frequencies and faster data rates. But beyond just 5G, you also have this increasing general demand for high-speed data transmission really across all sectors, and the continued expansion of wireless infrastructure everywhere. Plus, Think about it. Mobile data consumption just keeps soaring. And then you layer on things like the Internet of Things, cloud computing, smart technologies proliferating everywhere. All of this just increases the need for robust, efficient RF cables that can support these really high performance applications. And we're also seeing significant technological advancements in how the cables themselves are made, plus just wider adoption of advanced mobile tech. All of it feeds into this market expansion.
Okay, so with that kind of growth happening, what does the global picture look like for RF feeder cables? Are there particular regions, maybe hotspots, driving this demand, and why there?
Absolutely. There are definite regional dynamics. If we look at the current market shares, for 2024, North America actually holds the largest slice, accounting for roughly 35% of the market value. This dominance is really down to its strong existing tech infrastructure, its history as an early adopter of advanced wireless tech, and of course, the really aggressive 5G rollout happening, particularly in the United States. Europe follows pretty closely behind that with about a 30% share. That's driven largely by its sophisticated industrial applications and continuous improvements in telecommunications over there.
And which region is showing the most, let's say, dynamic growth? Where's the future infrastructure investment really concentrating, maybe?
Right, this is where it gets particularly interesting. The Asia-Pacific region is actually projected to be the fastest growing. It's forecast to bump up its market share from 25% in 2024 to around 28% by 2025. That reflects a higher CAGR, about 10%. And this surge, it's heavily fueled by massive investments, both government and private, pouring into telecommunications infrastructure. Think countries like China, India, Japan. That's coupled with really accelerated industrialization and just rapid adoption of 5G and advanced wireless technologies across the whole region. A lot of it is greenfield deployment too, building new infrastructure from scratch, which just drives huge demand for these cables.
Right, makes sense. Now, with all this growth and regional variation, who are the main players? Which companies are really driving this market forward with their innovations and strategic moves?
It's definitely a highly competitive space. You've got several leading companies really setting the pace. TE Connectivity, for instance, held about 15% market share in 2024. Amphenol and Molex were following closely with around 13% and 11%, respectively. These companies, they invest heavily in R&D, developing innovative products to stay ahead, often specializing in unique cable designs for very specific, demanding applications. We also see a lot of strategic moves, things like mergers, acquisitions, partnerships. Those are common tactics they use to, diversify their product lines and expand their global reach. And we should probably expect new players to emerge by 2025, especially coming out of those booming Asia-Pacific economies, mainly because the continued push for 5G deployment keeps creating significant new opportunities.
It's really striking how foundational these cables are, but I have to ask, how do they actually stack up against alternatives? Like everyone talks about fiber optics and its incredible speed. Does RF feeder cable really have a distinct advantage, or is it just, one option among many?
This is where we get that aha moment you mentioned earlier. Because, yes, everyone hears about fiber's raw speed, but the real insight here is actually about resilience and how things work in the real world. RF feeder cables aren't just some alternative. They actually hold a dominant position in key sectors like telecommunications and broadcasting. So yes, fiber optic cables are amazing for incredibly high-speed data transmission, no question. But RF feeder cables are often preferred in specific, often mission-critical applications. And that's because of things like their lower attenuation, meaning less signal loss over distance, their immense robustness, they can handle physical stress much better, and their flexibility. This makes them unequivocally more suitable for certain wireless communication and broadcast systems, places where you absolutely cannot afford signal degradation from physical stress or environmental factors. Or maybe where you need to deliver power alongside the signal, which fiber can't do easily. Think harsh outdoor installations, industrial robotics, certain military applications. Fiber just wouldn't hold up or be practical there.
Can you give us a sense of that dominance in numbers? Like what's the market share breakdown between these types?
Definitely. So in 2024, RF feeder cables accounted for roughly 70% of the market share in this specific application space. Now, to put that in perspective, traditional coaxial cables, the kind you might have for older cable TV, were at about 20%, and fiber optic cables only represented about 10% in these particular contexts. And looking ahead slightly, the share for RF feeder cables is actually expected to nudge up a bit, maybe to 72% by 2025. That's primarily driven by those ongoing needs of 5G infrastructure, which demand exactly these kinds of low-loss, high-performance, and reliable cables. It really highlights a clear ongoing preference for them in applications needing reliable, high-frequency signals over distance, often in challenging spots.
Okay, that clarifies their unique role. But, every powerful technology seems to have its vulnerabilities, its sort of Achilles heel. For RF feeder cables, it sounds like it's sensitivity to environmental factors. What are the main challenges there, and what actually happens when they're exposed?
Yes, that's indeed a significant obstacle. RF feeder cables can be particularly sensitive to things like temperature fluctuations, humidity, and also mechanical stress bending, twisting, that sort of thing. And these aren't just minor annoyances. They can cause real problems, significant signal degradation, increased signal loss, even physical damage to the cables themselves. And ultimately, that leads to compromised performance and, crucially, reduced reliability.
So how do those factors specifically cloud the issues? Can you give us some concrete examples of what's happening inside the cable?
Sure, so take extreme temperatures, for instance. Hot or cold, they can actually alter the physical properties of the materials in the cable. Think thermal expansion and contraction. That can affect the precise spacing between the conductors and the dielectric material, which directly impacts signal integrity. Humidity and moisture, if they manage to get inside the cable jacket, can lead to increased attenuation. Basically, the signal gets weaker, or in worst cases, even cause short circuits. And then there's mechanical stress. If you bend a cable too tightly or twist it excessively, you can cause permanent damage to the internal conductors or the shielding layers. That results in irreversible signal loss or distortion. And in those highly sensitive applications we talked about, like military comms or high-frequency broadcasting, any degradation in signal quality can be absolutely detrimental. It's just not acceptable.
That's a really critical point. So if the challenge is partly the cost of making these cables super resilient, does that mean future innovation is more about finding cheaper, robust materials? Or are we looking at maybe totally new cable designs that inherently bypass some of these environmental issues?
That's an excellent question, and it's really both. Manufacturers are actively working on it from multiple angles. They're developing cables with enhanced durability, sure, but also looking at materials with better environmental resistance right from the start and designing cables with higher shielding effectiveness to keep interference out. So it's a mix looking for new, more robust materials, yes, but also exploring innovative cable architectures and designs that are just inherently less susceptible to these external factors. The challenge, though, as you hinted, is that the costs associated with these more advanced, more resilient cables can often be prohibitive. It unfortunately limits how widely they can be adopted, especially quickly. And this cost barrier isn't just, an inconvenience for the manufacturers. It directly impacts the speed and quality of network rollouts, particularly in developing regions or maybe less profitable areas. It forces this tough trade-off between getting the ideal performance and sticking to economic reality, which can have long-term effects on network resilience and capacity.
Okay, but the industry isn't just standing still because of these challenges, right? Despite the costs and difficulties, what can we expect to see in terms of future developments? What innovations are pushing the boundaries of RF feeder cable performance?
Oh, not at all. There's a really strong focus on enhancing performance, especially for the next generation of communication systems. A compelling example of a recent step forward actually came in September 2024. A company called Pasternak introduced some new high-frequency connectors. These were specifically designed for semi-rigid coax cables in those really small 0.034 and 0.047 inch sizes. They made them available in various interface types too, like 2.92 millimeter, SMA, SMPM, and 3.5 millimeter. Now, what's significant about these, particularly the SMPM type in those tiny sizes, is that they point directly to a critical trend, miniaturization. They allow for much denser packing of components in really crowded spaces. That's absolutely essential for things like compact 5G, massive MAMO antenna arrays, or small cell deployments where you need to ensure signal integrity, but space is at an absolute premium.
Right, smaller connectors for smaller spaces. Beyond just the connectors, though, what other trends in the actual cable design or materials are shaping the future?
Well, we're definitely seeing this increasing push for miniaturization and higher efficiency across the board, not just in connectors, but in the cables themselves. As wireless systems become more compact and integrated, the cables simply have to follow suit. They need to become smaller, more flexible, yet somehow capable of handling even higher frequencies and power levels, all within that smaller footprint. So there's significant innovation happening in new materials and designs. Things like improved dielectric materials that offer even lower signal loss and more advanced shielding techniques that are better at blocking interference.
And how will these kinds of innovations broaden where these cables are used? Where else might we expect to see RF feeder cables making an impact down the line?
Well, these advancements will definitely expand their applications significantly. We're likely to see them move more into industries like aerospace, where lightweight, high performance cables are absolutely crucial. Also in automotive, especially with all the connected vehicle systems coming online, and within industrial automation too, connecting things like precision robotics and smart factory sensors. Basically, RF feeder cables are really poised to play an increasingly vital role in supporting this growing demand for high frequency applications everywhere. Think the Internet of Things, all sorts of connected devices, smart infrastructure. They're essentially enabling the very fabric of our interconnected future.
Okay, so to kind of wrap up our deep dive into RF feeder cables, we've really uncovered a market that's on a truly robust growth path, hasn't it? It's propelled mainly by that global expansion of 5G and its just ever-increasing demand for high-performance communication systems. And crucially, we're seeing this continuous innovation in the materials and the designs, which are directly tackling the challenges and constantly pushing the boundaries of what these uh, unseen connectors can actually achieve.
Exactly. And maybe as a final thought for you, the listener, to consider. As you think about that seamless connectivity you experience every day, your smartphone buzzing with notifications, maybe the smart city infrastructure starting to appear around you, consider how understanding the silent, absolutely vital role of these RF feeder cables might change how you perceive it all. And maybe ask yourself, what other hidden engineering marvels do you think are quietly underpinning the technologies we so often take for granted, just making our digital lives possible? Something to perhaps mull on until next time.